Hi everybody, we are Team 125 and we are happy to be your guides for your upcoming design competition.
Hi everyone, my name is Elsa and I'm in mechanical engineering. I grew up in Portland, Oregon and got into engineering because of an awesome teacher I had in high school who recognized my interest in his technical classes and encouraged me to pursue engineering as a career.
My name is John Tijerina and I'm originally from Germany, and I got really into engineering because of my grandfather. He had always taken me to work and got me interested into the topic.
Hello everybody, my name is Anton Alexeyev and I'm from Moscow, Russia. I grew up in a family of mechanical engineers, so I was really interested in the profession from a very early age. Growing in a family of mechanical engineers, for me the profession always represented individuals that are very determined, disciplined, and creative. After coming to college, I also realized that engineers make great friends and colleagues too, which helps you tackle any problem that you might face.
Before coming to college, my typical idea of an engineer was someone that was a little weird, a little nerdy, and had fun once in a while. I thought that an engineer was someone who took a problem and solved it on its own. After coming to college, I realized that engineers are really a part of a bigger puzzle. It takes multiple different types of engineers, mechanical engineers, electrical engineers, civil engineers, to come together to create a solid solution.
Before coming to college, I had no idea what engineers actually did or what they were really like. I thought they were antisocial and liked to work alone. But after coming to college, I found that engineers were really friendly and it's necessary to collaborate with each other to work on projects. And it's especially important to communicate ideas effectively and efficiently, and it's crucial for project success.
Engineering teaches you how to approach and solve problems in a structured, systematic way. It also tremendously improves your decision-making capabilities. Plus, you do all this through the design and solution of real-world problems. In addition, engineering is a lot of fun.
I feel like the most useful concept you learn in engineering is problem solving. This will not only help you as you advance further in your career, but also in your personal life. For example, living on my family's farm, we had stuff break all the time. So the ability to quickly assess the situation, come up with a solution, and then implement it really helped us save a whole lot of time and money, which along the way was actually pretty fun.
Engineering is useful in so many different ways. As engineers, we design and create basically everything that people use, from cars and planes to pencils and desks. We're involved in food processing and facilities, we work in the ocean, we work in space. Everything you come into contact with probably had an engineer's influence, and that's really cool.
I really like to invest my free time into my education. That's why I read a lot and try to learn as much new information as possible about any topic I might be interested in. In addition, I also really like to socialize and travel, which helps me broaden my horizons and gain new valuable experiences.
In my free time, I really enjoy barrel racing and rock climbing. But in the future, I would like to start my own company. So I play around with different ideas and designs I come up with and try to determine if they'd be good products in people's lives.
In my free time, I like to weightlift, read books, and spend time outside. This summer, I got really into backpacking and kayaking. And I think in the future, I would like to travel to different countries and immerse myself in their culture.
Now that we've met and you know a little bit more about us, let us introduce you to the project we'll be working on together over the next few months. Oregon State University recently received a large sum of money, called a grant, to build this ship called a Regional Class Research Vessel, or RCRV for short. These RCRVs are used for marine research. In the past, these research vessels featured launch and recovery systems that were labor-intensive and dangerous to both operators and the vessel. They were operated using pulleys and manual labor. Because the research equipment is not properly stabilized, ocean waves cause the equipment to swing in an uncontrolled manner. It should be noted that this equipment can weigh upwards of 2,300 pounds. This amount of weight swinging freely can cause tremendous damage to both the equipment and the vessel, as well as injury or death to the individuals handling the equipment.
mission is to design and build a functional model of an improved launch and recovery system that will be used on the new RCRV. There are several main features that we focus on, all of which are based on the customer requirements. Our goals are to make the model transportable, durable, and interactive. To determine whether we are successful, we will test our customer requirements using the engineering specifications. Engineering specifications are measurable parameters. For example, the engineering specifications for the customer requirement of transportability are that the mechanism fits within a 2 by 2 by 3 foot box and that it weighs less than 55 pounds.
One of our main concerns is limiting the degrees of freedom on the equipment or directions in which the research equipment will swing when attached to the cable. How would you limit the swinging of an object? Try this out over break. Tie a piece of string to something such as a ping pong ball or pencil, let the object hang freely while holding on to the other end, and extend your arm out and back in as if you were a launch and recovery system. Figure out ways to limit that swinging to a single direction, such as back and forth.
Dashing through the snow in a one-horse open sleigh, o'er the fields we go.